Welcome to homework.
All right, for this first graph, it is increasing where it's going uphill left to right, okay? I've highlighted in blue, that would be from 3 not included to infinity, because it includes going forever by that arrow. So from 3 not included to infinity. It's decreasing where it's going downhill. Just what I've highlighted here left to right is going downhill, so because of the arrow, it would be from negative infinity to an x value of negative 3. It is constant where it is flat. So from negative 3 not included to positive 3 included. So you use the bracket. The domain of this function is all reals except for negative 3, because there's a hole in the graph, and that would be it, because even though it's not continuous, it still has an output with an input of 3. So it's all reals except for negative 3. So that would be negative infinity to negative 3 not included, union negative 3 not included to infinity. The range, it goes as far down as 1 on the y-axis, but it doesn't include it, and will go up forever. So from from positive 1 not included to infinity. It is continuous from negative infinity to negative 3. It's continuous from negative 3 to 3, and from 3 to infinity. And it's not continuous. Its values of discontinuity are at negative 3 and positive 3. In your next graph, determine if it's even, odd, or neither. Graphically, it's even if it's symmetric about the y-axis, which this is not. It's odd if it's symmetric about the origin, which it is not. So this is neither graphically. Algebraically, you find f of negative x, and then compare that to the original. Well, negative x squared is x squared. And because when we put in f of negative x, if it's equal to f of x, it's even, which it is not. It's different. And if it's equal to the negative of the function, it's odd, which this isn't either, because we would want it to actually be like negative of the whole thing, which we can't do. If we're going to actually, we can say that this is the negative of x squared plus 5 over x. That would be algebraically equivalent, so this would be odd.